These are the solutions for the first practice quiz for quiz 5. So it starts out with questions about the discriminant. So you need to calculate these correctly and then say the number of solutions. So this is negative 16, meaning 2 imaginaries. Number 2, 49. This is a perfect square, so you can square root it perfectly, meaning that we have 2 of those. Number 3 is 0 when you do so that means 1, and this is where this occurs at the vertex, and you get the same factoring twice. And then number 4 is 12, and this is irrational. So 1 and 4, there would be no factoring on those. And then 2 and 3 would have factors. 5 and 6. So the difference on these is that you have, we'll write down the b squared minus 4ac here, 0. Okay, that means that that's going to be the same factor twice. That you're going to have decent rational solutions. These will both be factorable. So you might want to start with the shell. So negative b plus and minus the square root of the discriminant, b squared minus 4ac, so that 841 will go there, over 2a. So 841 square roots perfectly into 29. So this is negative 1 plus and minus 29, not the square root of 29. It's square roots into 29. So on these problems, you're going to have things that work. Your answers will be fractions or integers. So negative 1 minus 29, negative 30 over 12 is negative 5 over 2, and then negative 1 plus 29, 28 over 12, which is 7 over 3. Little calculator work there if you need to do it. Number 6, the discriminant is 0, so start with your shell again. And so A is 4, and then B is 4. Just make sure when you do your b squared minus 4ac that you do those, we'll do number 1 here, that you use parentheses. Anyway, so 0 is so we end up with negative 4 over 8, which is negative 1/2. Twice. So the factors would be 2x plus 1 times 2x plus 1. The factors here are 2x plus 5 times 3x minus 7. Don't forget, the factoring is always related. You should always be going through that in your mind all the time. Okay, so 4 problems here that you need to start off with by doing this. So it's going to work a little faster here. 72 is the b squared minus 4ac. So 8 plus and minus square root of 72 over 2 times 1. So 72 will break apart as 6 times the square root of 2. So we have an 8, a 6, and a 2. So 2 will divide into all of that, leaving us with negative 4 plus and minus 3 times the square root of 2. The 1's on the bottom, that we won't change that at all. We won't write that, I meant to say. So 820 is the value, and then we are going to do the shell again, plus and minus square root of 20 over 2 times 1. This is 0. B is 0. Square root of 20 is 2 times the square root of 5. So we have plus and minus 2 times the square root of 5 over 2. So this ends up being a little different. So on this page, all of these are irrational problems. So they would have no factoring if you actually tried to go and do it. So this gives you 17. So when we do this, over 2a. So this will not at all reduce because the square root of 17 will not reduce. There's no largest perfect square that will go in there. And number 10, b squared minus 4ac is 13. So all the same thing, 5 plus and minus 13 over 2 times 3. So 5, 1, and 6, nothing will go into all of those except for 1. So sometimes it does not reduce out. And I try to give a healthy number of those. So final page here for the spiral, just dealing with complex roots. Okay, solve each of the following. So this is negative 16. And then check your answer. Don't forget to do this part. So we have, so b is 0. So negative 16 is 4i. This will be 4i. So plus and minus 4i over 2. So check your answer using one of the roots. I'm going to take 2i and do this. So this is 4i squared plus 4. This is the line I would need to see, plus 4. So 2 squared and I squared. 4i squared. Remember that I squared is negative 1. You could also put in negative 2i here and square that and get it. 12 part A, if 3 plus I is a solution, then 3 minus I. So there is a rule with imaginary solutions that they occur in what are called conjugate pairs. So what's a conjugate pair? If there's no number in front, they're opposites. If there is a number in front, the signs switch. So 3 plus I, then 3 minus I. Or if I gave you 3 minus I, then 3 plus I. If I said 5 plus 2i, then 5 minus 2i is a solution. So now what we have to do is we have to take these two and figure out a quadratic that they belong to. So this is a little trickier in doing this with imaginary numbers. So we're going to use this formula to do it. This will work for any roots. Where a is 1, this is one way to do it. B is the opposite of the sum of the roots. So this is where all the work we did with, so this will be negative 6, with multiplying and adding comes in. And then C is the product of the roots, 3 plus I times 3 minus I. And so this would be 9 minus 3i plus 3i minus I squared. The i's drop out. Remember, I squared is negative 1, so that's like saying 9 plus 1, which is 10. So x squared minus 6x plus 10. Now what you can do is you can check these with your polysymbol if you put on, you have to get the mode right though. So you have to go under 8 to a plus bi. And it will do it. It will actually tell you those solutions, negative 6 and 10. So 3 plus I, 3 minus I. It will tell you those, and I believe the online calculator will do the same. Okay, so spiral problems, factoring, of course. Of course. So I'm going to go fast through these. So root 7/3, negative 5/2. So we have 3x minus 7, 2x plus 5. Remember, x gets multiplied on the bottom. Opposite sign and then the numerator. This negative 1/2 twice. It's a double root, meaning that the vertex is sitting on the x-intercept at negative 1/2. Make sure you check for a common factor. I haven't said that, but that's part of this. 3 times 2, 6, we're good. 2 times 2 is 4, we're good. Find the vertex of. Okay, so this one's pretty easy. You just look at, remember it's like this, a times x minus h squared plus k. So you have to fit it to this. So h is negative 3 and k is negative 6. When you write it to fit that, it's 2 times x minus negative 3 squared plus negative 6. So you have to write it to fit that, and that makes h the opposite of what you're looking at. This one you can use your table on, or you can do the negative b over 2a. I'm going to use the table on to highlight the idea of the pattern on the table. Let's see if we can find it here. If you can't find, oh, there it is. 228, negative 28. 2, negative 28. If you can't find it on the table, you have to do negative b over 2a. So that's the x value of the vertex, which is 2. So let's say it was 2.5, you'd have to do that first. So always know there's a way if you can't find it on the table. So that's practice quiz 1.